All right, Chapter 6, Section 4, Grandmaster video, some critical thinking problems. So first we have a linear function of the form f of x equals ax plus b is given, where a and b are some unknown constants. We are given some points, however. We're told that f of 1 is 4 and f of 2 is 10. What that means is, first of all, we know this is a straight line because we're told it's linear. Okay. What this means is these are points on a graph. If we chose to draw one, we could plot them. This means that when x is 1, f of 1, or y, when x is 1, is 4. Similarly here, if x is 2, y is 10. So these are 2 points that satisfy this relation, this function, even though we still don't know what a and b are. Well, I'm going to use a technique. Okay, there are different ways of solving this problem, but I'm going to use a technique that we've already looked at, and that was when we had points and we were trying to determine whether or not they formed a linear relation. And we just looked at how the values changed from one to the other. So I'm going to apply that technique here. We already know it's linear, so we don't have to determine if it's linear or not. That's already given. So as x increases by 1, y increases by 6. So that's the rule that's established. Okay? So any other point that we come up with has to obey that rule. So the next coordinate, if we chose to make it up, the next x value, of course, would be 3. Okay, therefore y would have to go up by 6, so this would be 16. Okay, well, this technique is useful because I'm going to do one point to the left, and you'll see why I do that in just a sec. So if I'm going to the left, now x is decreasing by 1, so this is 0, and y has to decrease by 6, so this would be negative 2. Well, why that is useful is because if you substitute x is equal to 0 into here, and you multiply it by a, well, 0 times anything is 0. Okay, so in other words, a just disappears off the face of the earth. So we are told that, hang on here, f of 0 is negative 2. Okay, that's from my ordered pair. Well, what that means is negative 2 must be equal to a times 0 plus b. Okay? It has to satisfy that equation. Well, the reason why this is so useful is because a just disappears. Okay? A times 0 is just 0. So in fact, all you get is negative 2 is b. So we've actually found one of the unknown variables that we wanted. Okay? So now, our function, we don't know it completely yet, but we can write out a little bit more. Instead of saying f of x is ax plus b, we know that it is ax plus negative 2, or just minus 2. Okay, so we were able to fill in this missing piece. So now the only thing that's unknown is a. Well, from here on in, we can use any point. We don't want to use this one again because a would disappear. So let's pick this one. Pick any other point. Any of these would work. So we know that f of 1 is 4. In other words, what that means is 4 is equal to a times x, but x was 1, minus 2. Okay, well, that's a basic equation I think you can solve. A times 1 is just a. And I think you can solve for a. It's pretty simple. Just add 2 to both sides. And we get 6 is equal to a, or a equals 6, whichever side you prefer to work on. All right. Well, now that we've figured out our two unknown values, a and b, we now know what the function is precisely. We can actually use it to evaluate specific numbers. any number. So we want f of negative 3, meaning what's my y value when x is negative 3? So I'm actually going to write down the entire function because we know what it is now. F of x is 6x minus 2. Because 6 and negative 2, that's what we figured out over here. But now we're evaluating this at x equals negative 3. So we're going to work it out. So that is 6 times negative 3 minus 2. Okay, I'm going to work down. 6 times negative 3, that is negative 18. Subtract 2 gives you negative 20. Okay, so we're done. You don't have to write the ordered pair. It didn't ask you to, but I'll throw it in, why not? So that means when x is negative 3, y is negative 20. So that's what I would plot on a graph. Okay, but that's my y value right there. Right, and then next, we want to determine the value of x when f of x is negative 62. So once again, f of x just means y. So they're just giving us the y value already, and we have to work backwards using a bit of algebra to solve for what x has to be. All right, so we know our original function, of course, but I'm just going to replace the y with negative 62. Put that in red. And that equals 6x minus 2. So we haven't been given the x value, we've been given the answer, the y value, and we just use algebra to work backwards. So we need to solve for x. So we add 2 to both sides. Okay, so be careful. Negative 62 plus 2, that is negative 60, equals 6x. And to solve for x, I can finish that by dividing both sides by 6. There we go. Those cancel. So we get x is, and negative 60 divided by 6 is negative 10. So there we go. So that's the x value, meaning the ordered pair, if x is negative 10, y is negative 62. All right, for this next example, notice I have a calculator here, so I am going to be using one. So this says, in air, the speed of sound depends on the air temperature and is given by the equation S of t equals 2.2 t plus 1192, where S is in kilometers per hour, so S, I guess, for speed of sound, and t is your temperature in degrees Celsius. Okay, so depending on what temperature it is outside, that actually has an effect on how fast sound can travel. So the first part asks, what is the speed of sound at an altitude of 10 kilometers? And we're assuming that at that altitude, the temperature is minus 55 degrees. Okay, and that's about right. When you go that high, the air starts to get pretty cold. All right, so basically it's asking us, what is S of negative 55? In other words, what is my speed of sound when the temperature that goes into this equation, this function, is negative 55? Okay, so that becomes 2.2 times the temperature, which is given as negative 55, plus 1192. Okay. And 2.2 times negative 55, we get negative 121, but we have to add 1192, so that is 1071. Okay, and this is in kilometers per hour. There we go. Next part, at what temperature does the speed of sound equal 1,000? Okay, so this would be kilometers per hour. So we're going to have to work backwards. So in this example, they're telling us what the speed of sound is already. What temperature does it have to be in the outside air for it to be at this speed? Okay, so we replace the s of t with the 1,000, and then we just solve for t instead. So that means 1,000 equals 2.2 times the temperature plus 1192. So let's just solve for t. I'm going to subtract 1192 from both sides. Okay. And I'm going to get negative 192 equals 2t. And I want to solve for t, so I just divide both sides by 2.2. Okay. I'll put this in red. They cancel. So let's work that out. And you're going to get a decimal, but I'll round. Now, as soon as I round, I'm going to put a little dot over this equals. Just means it's approximate. And the temperature is approximately minus 87.3, and this would be in degrees Celsius. So I'll put that in a box here. There we go. Okay, so if the temperature outside is approximately minus 87.3 degrees Celsius, or about minus 87 degrees, the speed of sound in the air will be about 1,000 kilometers per hour. So there we go. All right. The airspeed of a jet is often expressed as a Mach number. What that means is how many times the speed of sound it is traveling. So given that m, gets for Mach, m of v equals v divided by s, where m is the Mach speed and v is the speed of the jet, calculate the Mach speed of a jet traveling at 2,500 kilometers per hour when the temperature is negative 65 degrees Celsius. So what they're asking you for is, what is m of, and the velocity they gave you was 2,500. Question mark. That's what we're trying to find. Okay. Well, we could plug that in here, but then we'd have to divide it by s. Well, we don't know what the speed of sound is, so we actually have to work that out first. So we know s is defined up here. So let's figure out what the speed of sound is at this temperature. So s of negative 65 is equal to 2.2 times that temperature plus 1192. And take your calculator, work that out. You get 1,049. This, of course, is kilometers per hour. Okay, so that is the number we get to use inside here. So m of 2,500 is equal to v, which is 2,500, divided by s, which we just determined was 1,049. Okay, the units are actually going to completely cancel out, okay, because both of these are in kilometers per hour, so a Mach number is unitless. So let's work that out. I'm just looking at this, I can tell we're going to have a number bigger than 1. It's approximately I'll say round to the nearest tenth, 2.4. So it means that this plane traveling at 2,500 kilometers per hour at minus 65 degrees Celsius is traveling at Mach 2.4, meaning it is 2.4 times the speed of sound where he is flying, or she.